Hello and welcome to our video demo for our Lab4 clock project.
When the alarm clock is first turned on, the current time feature automatically begins if none of the other switches are on. You can easily switch the 24-hour format to the 12-hour format with no change in the current time. You can also set the time by flipping the switch, which will then make the seconds value go to 0, but keep the hour value and the minute value the same.
You can see as well the AM and PM settings for our 12-hour clock, as well as the continued passing of time as the time continues to go and the seconds increase and increment on our clock overall. Additionally, we had some trouble getting our alarm to work consistently, but it was working on and off at some points.
The system module is by far the most important module of our program. Getting all of the necessary inputs from the constraints file as well as passing the outputs back to it. It starts off by calling all of the switches modules that get the necessary input in order to manipulate the values that need to be processed in order for the set time and the alarm clock to change. The clock ALU handles all of those inputs and based on the inputs makes necessary changes to the values that will then be passed to the 7-segment module. Before it is passed to the 7-segment module, however, it goes to the 12-hour mode module, which, depending on whether it is a 12-hour clock or a 24-hour clock, will make necessary adjustments to the display.
The 7-segment display combines this all together to be displayed on the 7-segment display on the FPGA board. We used some of the saving code from an old lab and just sort of combined it with what we did for this. The 1s, 10s, and 2-bit switches modules are all also very useful and very similar because they serve pretty much the same purposes for different sets of digits.
One very interesting aspect of the clock ALU module is this always block right here. Depending on whether the reset switch is flipped, the set alarm switch is flipped, the set time switch is flipped, it will make necessary adjustments to the outputs that will be needed for the 7-segment display. If the reset is switched, then everything goes to 0. If the set alarm is switches on, then the alarm values have to be incremented. If the set time switches on, then all of the values that are correlated to the time are adjusted. But if none of those are on, then the current time aspect of the clock operates on a basis where it increments every second, which will then lead into the minute, which will then lead into the hour. This project was very interesting because we combined a multitude of topics that we learned about in this class. However, one major failure that we encountered was the keyboard not being able to properly input the numbers for the set time nor the alarm clock. However, one of the major successes that we encountered were being able to use the switches, and that was a lot simpler than using the keyboard.
Yeah, it was disappointing that we weren't able to use the keyboard like we originally planned, but I think we made the best of it. I don't know a ton of alarm clocks with number pads for inputting the time, so I think it worked out. Additionally, I think, I wish we'd been able to be more consistent with our alarm. It's just something that we were kind of struggling with getting the timing right on, which is why I think we had some trouble with it. But I think we can see that that's something we want to try and improve on in the future. And I think it's interesting that we got to build a bit more on some of our older stuff, like with the 7-segment display on this lab.